Hey everybody, so we're going to be working on example 3 and the last monitoring progress for these notes. So example 3 says, you are building a lean-to shelter starting from a tree branch as shown. You can construct the right end so it is similar to the left end using the angle measure and the length shown. Oh sorry, let me read this again. Can you construct the right end so it is similar to the left end using the angle measure and length shown? And here's my little drawing. It might not look as pretty as the picture they put in the book, but it doesn't need to be. What we care about in this example is going to be the triangles, right? So I'm going to go ahead and I'm just going to take these apart. I know that the one on the left is smaller, right, because we have 6 and 10 feet. So I'm going to draw these triangles. So this is 6. This is 10, and they're also telling us that this angle right here is 53 degrees. And then we also have a slightly bigger triangle that we think we're suspicious that it's going to be similar. And once again, this angle is 53 degrees. And we know that this side is 9 feet. We know that this side is 15 feet. So now, by this point, we should have already read over the side angle side similarity theorem. And so that's what we're going to be employing here. We need to make sure for the side angle side similarity theorem, just like the congruence one, we need to kind of make a sandwich, right? We need to make a side, the angle is in the middle, and the other side sandwich. In this case, we don't have to verify that they're congruent. We have to verify that they are in proportion with each other. So what does that look like? Let's see. So if these two are similar, we're going to need to have this side and this side correspond. So let's see, 6 over 9, corresponding side, and should be equal to the other side that they give us, which is 10 over 15. So we have this. Typing this in the calculator or solving it very briefly, we're going to get that 6 divided by 9 gives me 2/3. 10 divided by 15 also gives me 2/3. So we have this is 2/3, 2/3. So the sides are in proportion. And so let's start building this scenario, or this explanation, this proof, sort of explanation of a proof. We're going to say that, ooh, and you know what I forgot to do? I forgot to label my vertices. Very important. This is F, G, H. This is A, B, C. And now we can build our solution. We can say, since FG, segment FG divided by segment AB is equal to segment FH divided by segment AC, and angle F is congruent to angle F by reflexive property. Then triangle FGH is similar to triangle ABC by SAS, similarity theorem. So there it is, how to apply the SAS similarity theorem. We need two pairs of sides to be in proportion like we see here. And we need one angle in between them. If we can find those 3 things, we can prove that the triangles are similar. And now to finalize this section, we're going to be using the exact same ideas that we used before. So we need to explain how to show that these 2 triangles are similar. So let's see what we got. We have a big, both of these are right triangles, as we can see. And And so what we're gonna do is we're gonna have to check that the sides are in proportion like before. And so once again, I will check. I will do this right here. 24 over 18 should be equal to 28 over 21. Because those sides correspond. Now we have to make sure that these are correct, or that these actually are equal to each other. So 24 divided by 18 is 4 over 3. 28 divided by 21 is 4 over 3. So 4 over 3 is equal to 4 over 3. So that's check. We already know two sides are proportional to each other. And we also know the angle, right? We know that angle R is congruent to angle N because they measure 90 degrees, or because they are 90 degrees. So, once again, by side angle side similarity theorem, triangles SRT is similar to triangle PNQ. Remember, the order matters here. Make sure you're reading them in the same order. SRT, P, and Q. And last but certainly not least, number 4. Same deal, but now we have two inscribed triangles, right? We have kind of two triangles being put together as one. So just like with my previous examples, it's probably gonna be a good idea to draw these separately. Let me see. So how do I do this? So I'm gonna draw. Let me see which one's XZW. So XCW is this one. So I'm gonna draw this, and this will look like the following. Yeah, we're gonna do XZW. Like this, XCW. So this right here is a right angle. We know that this is X, Z, and W. We also know that this height should be 12, the base should be 16, and the hypotenuse should be 20. And then they're asking us to verify whether that's similar to triangle YZX, which is this one, YZX. And so just like before, I'm going to have to draw these in the same position so that it's easier to find my corresponding angles. I have a right angle right there. That tells me that this is Z. So because Z goes to Y, Z needs to go to Y up here as well. And then that leaves X as our remaining side. And you're probably thinking, hey, can we use angle-angle similarity to prove that these are similar? Yes, we can, but we don't want to do that. That's cheating in this section. We want to use the side angle side similarity. So let me write in the side lengths because I totally forgot. ZY is 9. Our hypotenuse over here is 15, and then we got that our base is 12. So again, if we are able to put these sides and these sides as proportions, and if they are equal, we're going to be able to prove this by SAS, since we already have that angle, that right angle, be congruent. So once again, we'll create the proportions. We're going to do 12 divided by 9 should be equal to 16 divided by 12. So let's see if that's true. 12 divided by 9 gives me 4/3. 16 divided by 12 gives me 4/3 again. So just like the one on top, we have our pair of corresponding sides. And because we have that angle Z is equal to itself, so angle Z is congruent to itself, we know that by SAS similarity theorem, triangle XZW. Ooh, that looks weird. I squeezed it in there. That should be XZW is similar to triangle YZX. So in other words, this one right here, in case you can't read this, that's an XZW, YCX.